Okay, today we'll be looking at ABC problems, things I remember from when I took algebra. Textbook had ABC problems, so let's just take a look at something we've done before. So let's say here I have the square root of 18x to the third times y to the fourth. And I want to simplify that because my index is 2. I'd be finding the largest perfect square root factor of 18, which is 9. So this would be a square root of 9. And then I'd find multiples of 2 that's less than or equal to 3. So that would be 2. So I'd have x squared. And multiples of 2 that's less than or equal to 4. Well, that would be 4. And so times what's ever left over. 9 times 2 would give me 18. I have an x squared, so I need x. X squared times x gives me x to the third, and then there. I have my y to the fourth. And so we would just simplify all of this as a perfect square, and so the square root of 9 is 3. And then if I take x squared divided by that index 2, I get x, or the square root of x squared is x. And if I take y to the fourth and divide that by 2, I get y squared. Or the square root of y to the fourth is y squared, and then finally times the square root of 2x. Okay, so but what we do to get back to here, to get to that, all I do is reverse the process. Okay, I reverse the process. With numbers, I'll take the number and I'll square it. So for example, I'll have 3 squared, and then but with the variables, I just multiply the exponents. Okay, so 1 times 2, so that will be x squared, and then 2 times 2, that will be y to the fourth, and then times the square root of 2x. And so that will be the square root of 9, and then x squared y to the fourth. If I multiply that by the square root of 2x, that will give me what I started with, square root of 18 x to the third. 2 and 1 is 3, and then y to the fourth. You see, that's what I started with. All right, so what we'll be doing is we'll be doing ABC problems. We'll want to figure out what's A, what's B, and what's C. All right, so let's do these here. Basically, we're just reversing the process. So let's take a look at the first example here. All right, so example, I have the cube root of ABC for negative 3x cubed y squared times the cube root of 4x. So here I go. I want to reverse the process. So I'm working with the cube root. So I'll take negative 3 because my index is 3. Remember, with the numbers, we're going to raise it to that index, so negative 3 to the third. But with the variables, we just multiply. So 3 times 3, that will be x to the ninth. And then 2 times 3, that will be y to the 6th. And then we'll multiply that by the cube root of 4x. Okay, so we'll have the cube root, negative 3 cubed is negative 27. X 9, y to the 6, all times the cube root of 4x. And now we'll just multiply. Okay, so we'll multiply there. So 27 times 4, that would give me 108. So this would be cube root of negative 108. And then I have x to the ninth times x, that would be x to the 10th. And then I have y to the 6th. So there. So A would equal negative 108, B will equal x to the 10th, and then C would equal y to the 6th. All right, so that's my A, B, and C. Let's just do another one. But again, we're just reversing the process here. That's all we're doing, which is good, because if you can reverse the process, then to simplify radicals, you'll be able to simplify radicals. So again, another example. So let's say here I have the square root of ABC. And for this one here, so 5x cubed y squared, the square root of 5x. So again, reverse the process. My index is 2. So I'm going to take So I'll have 5 squared. And then 3 times 2 is 6, so I'll have x to the 6. And then 2 times 2 is 4, I'll have y to the 4th. And then I'll multiply that by the square root of 5x. Now 5 squared is going to be 25, so x to the 6th, y to the 4th, times the square root of 5x. So then I would have had 25 times 5, so that would have been the square root of 125, and then x to the 7th, because I have an x to the 6th and an x there, and then y to the 4th. So a will equal 125, b will equal x to the 7th, and c will equal y to the 4th. So that was my A, B, C. Again, we're just reversing the process. With numbers, you have to raise it to the index. 5 squared. With variables, you just take the exponent and you multiply it by the index, and then stick it in the radical. Let's look at, now let's take a look at another example. Let's say here I have the 5th root of 8, and I'm going to multiply that by the 5th root of x to the 14th. And then, but in the end, I'll get x to the 5th times the 5th root of x to the 3rd. So let me clear that, the 5th root. Okay, so what was A? Well, what was A here? So again, we just reverse the process. Because I'm working with variables, I'll just multiply that exponent times the index. So I'll have, the 5th root, so I'm working with the 5th root. And then I'll put everything, so 5 times 5 is 25, so x to the 25th, and then I have an x to the 3rd. So this would have been the 5th root of x to the 28th. Okay, so what was A then? Well, if this is x to the 14th, and here I have x to the 28th, that meant A would have had to have been x to the 14th as well. So the 5th root of x to the 14th times the 5th root of x to the 14th. Right? See, I just reversed the process there. Right? With variables, it's easy. You just multiply the exponent times the index. 5 times 5 is 25, so x to the 25th times x to the 3rd, which is x to the 28th. And so that meant A then would have been x to the 14th. Another example, so here, again, we're just reversing the process. So let's say here I have the cube root of A, and I'm going to multiply that by the cube root of x to the 11th for x to the 4th times the cube root of x squared. Again, we just reverse the process. My exponent here is 4. My index is 3. With variables, we just multiply. So this is going to be the cube root of 4 times 3, so x to the 12 times x squared, and that would be the cube root of x to the 14th. Well, I have x, but I have x to the 11th there, which means then A would have been x to the 3rd. Okay, so A, so this would have been 3 times x to the 3rd times, the cube root of x to the 3rd times the cube root of x to the 11th. And when you add, you get 14. So A would be x raised to the 3rd. Okay, again, just reversing the process. Next couple here. So let's say here I have 27 over 64. And I'll have A and then divided by 3, but in the end I know I get 81 over 256. Well, what's A? Well, I'm taking the cube root of 27 over 64, and then I'm raising everything to the A. Well, the cube root of 27 is 3, and the cube root of 64 is 4. And I raise everything to the A. Well, A then has to be 4. Because, so A will equal 4. Why? Because 3 to the 4th over 4 to the 4th. That will give you 81 over 256. So A equals 4. Another example here. So let's say here I have, 25 over 36. And let's see here, 25 over 36. And I have all raised to the A over 2. And that's going to equal 125 over 216. Okay, so again, I'm taking the square root, okay, because my index there is 2, so I'm taking the square root of 25 over 36, and I'm going to raise everything to the A. Well, the square root of 25 is 5, and the square root of 36 is 6, and I'm going to raise everything to the A. I want 125, so that means A has to be 3. Why? Because 5 to the 3rd over 6 to the 3rd will give me 125 over 216. All right, just reversing the process here. And then the last two, which probably was maybe a little more difficult, but let's see here. I have I'm going to take the square root, and we only work with square roots with these here. And all I know is that equal 5x squared in the end times the square root of 6 over 3. All right, so how do we approach this here? Well, first let's work with this here. Okay, because my index is 2, I need to reverse everything. So this is going to be, so I'll have the square root of 5 squared, and then 2 times 2 is 4, so x to the 4th. Oops. 5 squared x to the 4th. So, and then times the square root of x over 3. Okay? But, okay, how did I get 3? Well, here, if I just ignore, so if I ignore just the AB, basically what I had, so I had the square, well, I had the square root of A over the square root of 3. But then in the end, I got 3, which meant I had to rationalize the denominator, so I had to multiply by root 3. Okay, I had to multiply by root 3 to get 3. Well, the very easy thing to do then, all you have to do is take that number, 6, and divide it by that, and that will give you what it was before you rationalize the denominator. I'm going to say that again. All you have to do is take 3, or that number 6, and divide it by that number 3, and that will tell you what was in the numerator before you rationalize the denominator. So here we go. So, well, 3 divided by 6. 3 divided by 6 is 2. So I'd have 5 squared, which is 25, x to the 4th times the square root of 2. 6 divided by 3 is 2. All over this, okay. All over 3, or this square root of 3, I guess, is square root of 3. We're trying to get, or in this case, yeah, the square root of 3. So, yeah. So we have, so this would have been then, so this would have been the square root of 50 times x to the 4th over the square root of 3. All right, so that meant A, so A would have been 50, and B would have been x to the 4th. All right. All right, so, and then one more of these. So, and you can verify that. So if I had the square root of, 50, yeah, A would have been 50 and B would have been x to the fourth. So 50x to the fourth over 3. Okay, 50. And again, if I just simplify that, the square root of 50 will be the square root of 25 times x to the fourth times the square root of 2 over the square root of 3. And so this would have been the square, so this would have been 5x squared, square root of 2 over the square root of 3. And then when I rationalize the denominator, I would have gotten 5x squared root 6 over 3, which is what I had when I started, 5x squared root 6 over 3. All right, and then the last one here, so again, find A and B. So A, B, this is 2, and in the end I had 9x cubed over the square root of 14 divided by 2. That was my final answer. So again, because I'm working with index 2, we'll just reverse everything. So this is going to be the square root of 9 squared, and then 3 times 2 is 6, times the square root. Okay, but again, this is easy. This is 14, and then this is 2. That's 14 and 2, so I would have multiplied. Okay, so I would have had the square root of 7, all divided by the square root of 2. Okay. So again, very easy. Just take 14 and divide it by 2 with these here, and you get the square root of 7. All right. So let's evaluate this. Well, the square root of 9 squared, that would be 81. X to the 6 times the square root of 7 divided by the square root of 2. And then 81 times 7, what's that, 56, 567? Wow, that's a big number. So 81 times 7 is 567. So this would have been then square root of 567 x to the 6 over the square root of 2. Okay, and then when so my A would have been, A would equal 567 and B would equal x to the 6. So these, they're a little more difficult, but all you have to do is keep in mind that you're just going to take that there and divide it by that, and then that will give you your missing number underneath the radical, and then you'll just simplify. 9 squared is 81, x to the 6 times root 7, which is root 567 x to the 6, all divided by root 2. And so, and that's what we started with. So we would have had the square root of 567 x to the 6 over 2, which is basically that. All right, so there, A would have been 567 and B would have been x to the 6. So we call those ABC problems. All right, so give it a shot at to try and answer some of those.